Hi everyone, this is Maverick Paul, the chemistry guru. Now in this week's video, we want to discuss a kinetics question calculating non-integer number of half-lives. So let's take a look at this question. I have a first order decomposition reaction as shown below involving AB decomposed to give me products. The half-life of the reaction is found to be 3.47 seconds. Question is asking what is the time taken for the reactant to reach 1/3 of its initial concentration. Now, the topic tested in this question, of course, is under kinetics, and given the half-life is 3.47 seconds. Now, what do we understand by half-life? Half-life is the time taken for the concentration of your reactants to reach to half of its initial amount. So, it is the time taken for me to halve the concentration of our reactant. Usually in syllabus, when we consider half-life, we're interested in integer number of half-lives. And for first order reactions, half-life is a constant. So we will expect if the concentration of our reactant at the beginning is x, after one half-life, which in this case is 3.47 seconds, the concentration of our reactant will be half x. And after another half-life, another 3.47 seconds, the concentration of our reactant will be 1/4 x. Another 3.47 seconds, the concentration of our reactant will be 1/8x, and so on. So basically, after every half-life, the concentration of the reactant will be halved. We notice after one half-life, after two half-lives, and after three half-lives, the concentration of the reactant is decreased to half x, to 1/4 x, and so on. It's actually not equal to 1/3 of its initial concentration. So we notice 1/3 of its initial concentration is actually somewhere in between half x and 1/4 x. And this means that 1/3 of its initial concentration is actually a non-integer number of half-lives. Now usually in syllabus, we're not required to do calculation questions based on this, but sometimes we do encounter prelim questions talking about this idea where we're dealing with non-integer number of half-lives. So what we will have to do is we will have to make use of a formula to try to calculate the time taken for me to reach 1/3 of its initial concentration. Alright, so let's take a look at the formula here. Ct divided by C naught is equals to half to the power of n. So how do we interpret this formula? Now Ct will be the concentration of our reactant at time t. C naught will just be the initial concentration of our reactant. Half to the power of n is actually the number of half-lives, which is also equal to the time taken divided by your half-life. We actually can make use of this formula to do calculation when we're dealing with non-integer number of half-lives. So let's try to apply this to this question here. We know that the concentration of our reactant is at 1/3 of its initial concentration. So therefore, Ct divided by C naught will be 1/3. And now what we want to do is we want to solve for n. So 1/3 is equals to half to the power of n. Then we can take natural log on both sides. So ln 1/3 is equals to n ln half. And I can do my calculation. I can solve for n. N is equals to 1.585. And we know that n is the number of half-lives. And this will also be equal to t, which is time taken, divided by half-life, which is given in the question, 3.47 seconds. I can sum all these values in. N is equals to 1.585. T, or the time taken, is the one we want to determine. Half-life is 3.47 seconds. So I can solve for the time taken. Time taken will be 5.5 seconds. So we can now answer this question. The time taken for the reactant to reach 1/3 of its initial concentration, the answer will be C, 5.5 seconds. Alright, so that was the discussion involving how do we calculate non-integer number of half-lives. Basically, we just have a formula that we need to remember to handle such questions. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.